Alright, hey, okay, so what this video is a response to Roosterteeth, Let's Play channel, whatever, about this whole coin flip, coin toss debacle that's happened, or argument, wouldn't necessarily call it a debacle. Anyway, in case, okay, I'm gonna explain what's happening first, why I'm doing this, and then I'll actually get to the crux of the issue. If you're new, if you don't know what's going on, Roosterteeth, they are a company, they make videos on YouTube, which basically consist of a bunch of guys playing games or doing stuff in games and trying to be entertaining. And it's very successful, I commend you for that. And what's happened recently was two of them, two of these guys, there's 6 of them, two of them named Gavin and Ryan have had this argument related to probability about a coin toss and whether increasing the number of times you flip a coin increases your chances of a certain type of outcome. Right. And because Gavin isn't really respected in the group in terms of in the case of academic matters, I'd say everybody instinctively believed Ryan, that Ryan was correct, and from what I understand, and that's how it stayed. I don't know how, I don't know the exact circumstances of the issue. I don't know exactly what's said. All I can surmise is what was said in the videos, and yeah, what was said in the videos, basically. And I could also argue against the comments that have happened on said videos, because this is YouTube and everybody started talking about probability and who was right, who was wrong. You can tell what my opinion is about who's right just based on the title of the video. Before we get to that, you might be wondering, well, if you've gotten this far, why is he doing this? Who is this guy? Why do you care? Why do you bother yourself with such? Well, because, well, why do anything? Why does Roosterteeth matter? Why does the entertainment that they provide matter? Because it's entertaining, and this is entertaining for me, I figure. Plus, I am to some extent frustrated with an issue like this, an issue that is very, very easily resolved, as I'll explain later. And arguments like this shouldn't really happen because they're very easily testable. And I'm also bothered by just the immediate ad hominem that happened, and everyone was like, oh, Gavin's wrong, Gavin's wrong, let's forget about what's happening, Gavin must be wrong, obviously, it's Gavin. So, yeah, that was an issue. Of course you might think, you know, if none of that appeals to you, if you have no empathy for what I just said, then whatever, I'm creepy, I'm weird, I have too much time on my hands, I have no life, whatever descriptive phrase comes to your mind, that's okay, I don't mind. I'm just here to have my say. So I'll explain what actually happened now, what this argument started with. Jeff, who is another person in Roosterteeth, him and Gavin were doing a video. Ryan was in the room. You can hear him in the his audio is very faint. This is how it started. The actual argument has spanned several videos of their videos, but the one I'm responding to is the one where chronologically the argument actually began, and I mean chronologically in time, in real life, not in the time that the videos were uploaded. Jeff and Gavin, to entertain the audience, what their video is basically they build things in Minecraft, that's it. What they do to entertain the audience is they propose these fairly ridiculous sexual thought experiments that are amusing in some way, and they indeed are amusing. I commend you guys if you're watching. So what happened was Jeff proposed a thought experiment to Gavin, and Ryan was in the room. Jeff said, look, you can have sex with whoever you want. Okay, you flip a coin, and you can have sex with whoever you want on the planet for the rest of your life. If you get the toss, if you get it right. If you get it wrong, you have to have sex with a man named Bam Bam Bigelow. I'll leave it to you to look him up. He doesn't look very friendly or pleasant or good looking, so that's that. And Gavin asks, well, how many coin flips do I get, right? Because the number of flips should affect your chances of the outcome. And Jeff says 3, and then Gavin's like, "Oh, those are pretty good odds," and Jeff's like, "Yeah, those are pretty good odds," and then Ryan's in the room, and Ryan's like thinking to himself, "No." And apparently he started an argument with Gavin, and at first Jeff agreed. He was like, "No, Gavin's right, the chances are higher." And an argument started, and in the video the screen went black, and it said that this went on for 5 minutes. So, and they skipped it because apparently nobody cares about the argument. I do. So, and apparently so does Gavin, because he keeps bringing it up, and I don't even know, I mean, I don't know how much time these guys spend in the same room a week. I don't know how much time they spend together, but in several videos this issue has been brought up, in several videos with Ryan, so I imagine Gavin brings this up fairly often, so maybe cumulatively they've argued about it for at least an hour, I figure. Maybe I'm wrong, maybe I'm exaggerating, forgive me if I'm wrong. Clearly it matters to Gavin, so let's, probably mostly because everyone thinks he's wrong, from what I understand. He's not wrong. Okay, so the contention was, for one, let's assume Jeff's thought experiment is basically like it's a game, really, it's a game. You win if you get what you called, you lose if you don't. Now I'm going to assume throughout this entire video that what you call is, your always call is that you call heads. Why heads? Because it's arbitrary and whatever, heads. I'm also going to assume for the first part that you don't switch what you call after each flip. I'll get to what happens if you do at the end of the video, but it does affect things. And from what I get it, the way I get it is that you have 3 coin flips. If you get heads once, which is what you're calling each time, you win. You win, you get to have sex with whoever you want. You don't get, you have to have sex with Bam Bam Bigelow. If you lose, which is if you lose each coin flip, as in you get tails all 3 times, then you get then you have to have sex with Bam Bam Bigelow. That's the game. So let's explore this. Where was I? I apologize. Anyway, okay. So the main issue with what Ryan said and what people in the comments said, and there's been a lot of comments, is basically there's contention about whether coin flips are mutually exclusive or not, or whether one flip affects the outcomes of other flips. It does not. This is well established. Physically, flipping this coin once doesn't affect the flip that happens in the future at all. That's true. That doesn't matter though. Probability, from what, you know, in probability, for one, the only thing that matters is the final outcome. I'm going to say that, and I'm probably going to repeat that a lot in this video. Second of all, oh, and forgive me, by the way, at any point, forgive me if I've misinterpreted the situation, or if I haven't understood, or maybe if it's already been resolved. I don't know if the issue's been resolved, if Ryan and Gavin have resolved it, or whatever. If they haven't, you know, this is, it doesn't really matter, because people in the comments haven't resolved them, and I'm talking to them as much as I am to the people I'm responding to. So, right, the other thing I was going to say was that probability isn't really physics. I mean, yes, each coin flip is physically independent, but probability is not physics. It's not, it's a mathematical framework that we use to predict certain results. That is it. It has no bearing on how things work physically. Now, I mentioned before that this is very easy to resolve, and one way you can easily resolve this issue is by testing it, and which would not take long, really. You get a coin and flip it 3 times, and then do that a bunch of times. Do that like 20 times, and then look at what you get. You will win based on the criteria for winning in Jeff's game, which is getting heads once. You will win 87.5% of the time, approximately. It'll approach that number as you do more trials. You will lose 12.5% of the time, because to lose you need to get tails 3 times. It is not 50-50. It's not 50-50 based on how people in the comments are based on what people in the comments are saying. Now, what was I going to say? Pretty much the situation with right. Also, sorry, for For the process of flipping it in real life, what you might want to do is a thing that people in the comments have said is, hey, well, if you flip it once and you get heads, you shouldn't flip it again. You wouldn't. You already win the game. True. So again, I challenge you, in real life, flip the coin once, flip a coin twice, flip it 3 times, and move on to the next trial. And do that 20 times, that's like 60 flips in total. If you get heads on the first flip, just move on to the next set. If you get it on the second flip, move on to the next set. If you get it on the third, also obviously move on to the next set. If you get tails 3 times, you move on to the next set. I guarantee you, if you do that, you will get 87.5. This isn't even up for debate. I know for a fact that the evidence backs me up here. So, all the possible outcomes, you have heads 3 times, tails 3 times. Okay, there's 8 possible outcomes. I actually have them written down here on this sheet of paper. Ignore the stuff on the right, left, whatever. These are the outcomes, right? I think you could see that. You have 8 different outcomes. Probability doesn't care about what happened to get there. In one of the videos, Michael said something about flipping all the coins in the air at once. That doesn't matter. It doesn't matter when you flip that. That doesn't matter. It doesn't matter when you flip the coins. It doesn't matter how you flip the coins. It literally makes no difference what procedure you do. You could flip one coin, you could take the other coin, take it to the moon, wait a million years, flip it again, then flip the third coin. It makes no difference how you flip the 3 coins. The results will always be within this category. It's always going to be one of these 8 things. And 7 of these 8 things have you win. The 8th one has you lose. If 1 out of 8 has you lose, your chances for losing are 1 out of 8, your chance for winning are 7 out of 8. That's the basic, simplest way to explain this. I'm going to try to dig a little deeper and actually look at why people have made the mistake. So the one argument I keep hearing is that, or reading I guess, is that, hey, if you get heads on the first flip, you don't have to flip again. So it's 50-50. It's 50-50 on the, yeah, but in that case it's 50-50 on the first flip. If you get heads on the first flip, the other 2 flips still, in the system, they still exist. All that does is it limits your possibility. If you get heads on the first flip, you're either in this situation, this situation, or that situation. It doesn't matter whether these other flips happened. It doesn't matter. The fact is, you got into one of those situations. If you flip tails the first time, well, you could still win. It just means you're down here in this set. Flipping the thing once puts you in this ballpark or that ballpark. That's it. Flipping it twice limits the ballparks even more. 3rd time gives you the final result. So, again, this is a little break. Right. What people were saying is that the coin flips are mutually exclusive, and to be fair, this is kind of ridiculous if you just extend the number of coins to like 1 million. Okay, look at all the possibilities. Let's look at the number of possibilities. With 1 coin flip, it's 2, really. Unless the coin miraculously lands on its side like this, which is extremely unlikely, but some astronomical chance that happens. Let's ignore that though, it's extremely small. So with 1 coin, it's 1 over 2. With 2 coins, you have 2 more possibilities, but you multiply it because it's heads, 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 tails, tails, heads, tails, tails. 1 over 4. 3 coins, you get another set of 2, and that you multiply by 1/2 again, so you get 1 over 8. 4 coins, 1 over 16, 1 over 32, etc. For an arbitrary number of coins, say n, the number of possibilities is 1 over 2 to the power of n. That's going to be the number of outcomes. And in every single situation, and no matter what number of coins, the way Jeff defined the thought experiment, you lose only if you lose each flip, which means in no matter how many outcomes there are, only one of them has you lose. All of the others have you win. Basically what I'm saying is that if you're given like a situation like this, you need to take it, because the more coin flips you're allowed to have, your chances for winning increases astronomically, and it converges to 100% the more coin flips you're allowed to do. Because to win, like, okay, Ryan kept saying this, like, 50%, 50%. People in the comments are like, chances of winning, 50%. If your chances of winning are 50%, then your chances of losing must be 50% as well. Right? Right. Because probability cannot exceed 1. Your chances of losing, well, if you look at this, your chances of losing are only there. Only if you hit tails 3 times. Your chances of winning are all up here. So you can win. So that means you get tails 3 times 50% of the time if you flip 3 coins. I think that's ridiculous. Flip 3 coins, see if I'm wrong. Do it. It's wrong. You're not gonna flipping tails 3 times is 1/8. That's your percentage chance of doing that. Like, what does Ryan? It's hard for me to understand what these people are thinking. Although I sort of understand where they made the mistake. I mean, if you extend the number of coins, if you say have 4 coins, 5 coins, let's say you're flipping 100 coins. All that needs to happen is the thing you called needs to pop up once. It's more likely with more coins, is it not? Because more trials, you're given the chance more than once. You're given the chance more often. It's 50% once, but with every number of flips that you get, your percentage increases. In fact, okay, I'm gonna throw in some terminology here. There's this thing in probability called a partition. What a partition is it's a set of all possible mutually exclusive outcomes for a given system. This system, 3 coins that we're flipping, that's the system. What's the partition? This is the partition. These are all the possible outcomes, and they're all mutually exclusive. Like, you can't have 3 heads up and 3 tails up at the same time, right? So, the mutually exclusive outcomes are the only thing you need to worry about. That literally is everything you need to know. The winning percentages, they're not found with every individual coin flip. You cannot figure out what percentage chance Gavin has to win if he flips a coin here or there. The only thing that matters, the only place when you're analyzing this, the only place that you can look to find what chance Gavin has of winning is here. It's at these fucking values. You look here, it'll tell you what percentage chance he has of winning. If you flip the coin 4 times, he has even more chance of winning, because then it's 1/16 to get tails 4 times. If you extend to 100, then he has to get, 100 tails. Think about how unlikely that is. Think about how unlikely it is to get tails 100 times. Those of you who think it's 50% of the time, you are incredibly wrong, is what I'm going to say. You're incredibly wrong, because if you just flipped 100 coins and you kept doing it, very unlikely that you would get 100 tails up. In fact, okay, I'm going to throw in some more terminology. You will have heard of this if you've studied statistics at all. There's this thing in statistics called the law of large numbers. I didn't make it up, it's a real thing. Go look it up on Wikipedia if you want. What it basically says is, for large measurements, like if you're flipping a lot of coins, then the average of the results, I guess, will converge to the expected theoretical value. As in, it'll converge to what we think is going to happen based on our understanding of how a coin flip works. In this case, 50-50, right? What that means is, if I'm flipping a large number of coins, the law of large numbers says that the more times I flip, I'm likely to get half of them to be heads, half of them to be tails, because that's how coins work. The expected value of 50%, the more coins I flip, I will get this. In formal terms, the limit, as the number of flips goes to infinity, the statistics I get will go exactly to 50%. Now, understand, this isn't saying that if I flip 999 coins and they've all been tails, that the next one has a higher chance of being heads. That's not what it's saying. It's saying that the overall result of having gotten 100 tails is in principle unlikely, and that in principle you will get heads and tails, and they're both going to show up, and they're both going to show up in equal quantities. Now, you don't need heads. Now, the thing is, to win Jeff's game, you don't need heads to show up that often. You need heads to show up once, and you have 3 flips to do it. My point again is that if you flip more times and you need heads only to show up once, the chances of that happening are ridiculously high. They are ridiculously high because of the law of large numbers, I guess, because you're likely to get equal percentages of both heads and tails. You're not likely to get a lot of tails and a lot of heads. If I flip 1,000 coins, 1,000,000 coins, half of them will be heads, half of them will be tails. That's what it's going to go to. You only need 1 heads, though. The idea that each coin is physically mutually exclusive doesn't matter for probability. And I'll show you why it matters in a sec, but that might be kind of complicated. Excuse me for a sec. Kudos if you're still watching. Okay, so I'm going to get into some more serious math here just to drive the point home. There's a formula in probability for what happens if you want 2 events to be true. Like in this case, you want 2 coin flips to be tail, or 3 coin flips, but let's limit it to, A and B, or coin A and coin B. You want coin A to be tails and coin B to be tails. To find out, when Gavin's going to lose. Right, well, the way you calculate that, if they're not mutually exclusive, is the probability of A and B both being true, or both coins being tails, is the probability of A multiplied by the probability of B given A. Okay? That's what it's equal to. In fact, this is where I bring up this formula, right? The one I have here, probability. In this case, of course, we don't have A. We have 3 coins, so that's A, B, and C. So the probability of C and B and A is equal to the probability of A multiplied by the probability of B given A. This is just how we represent that. Multiplied by the probability of C given A and B. Right? It's 3 things that we multiply. 3 things that we need to multiply. This is just, if you don't understand the formula, that's fine. And probability it's between 0 and 1. Every single one of these values will be between 0 and 1. That is a fact. That's how that's a property of the probability function. That's how probability works. So, let's calculate it. Well, what's the probability of A? What's the probability that the first coin lands on tails, which we don't want? Well, it's 50%, right? It's 1/2. So, the first thing we multiply is a 1/2. What's the probability of B being tails given A? Well, this is where the thing you guys were saying about how future coin flips are not affected by preceding ones, this is where that comes in. This is what everyone has been saying, this is what Ryan said, this is where that factors in, okay? Based on the formula, if the probability of the second coin being tails changes based on what the outcome of the first one is, then you factor that in. But it doesn't affect it, does it? The probability, hold on. The probability of B given A, it doesn't depend on A, does it? The probability of the probability of the second coin, it doesn't care whether A is tails or heads. It doesn't care if it's true or false. So the probability of B given A is the same thing as the probability of B, right? So that's also 1/2, right? It is. It's also 1/2. So then we have the probability of C given B and A. Well, that's just the same thing. Third coin, like Ryan said 1,000,000 times, like people in the comments keep saying, You know, the third coin flip, it doesn't care about the first two coin flips. It doesn't care about them, which means given that A and B are true, C doesn't, the percentage chance of C being true does not change. So what's the probability of C being true? Also 1/2. So what do you get? You have a half times a half times a half, which is 1/8, which is exactly what I started with. It's exactly what I said. Now, C, B, and A. Let's say that C, B, and A are just tails, tails, and tails. Probability of getting tails once, probability of getting tails a second time, probability of getting tails a third time, which is by the criteria that Jeff had in his thought experiment. That is the only time that you lose the game. That's the only time you get to have sex with Bam Bam Bigelow, is if you get tails 3 times. Well, the chance of doing that is 1/8, based on the formula. Now the formula is not wrong. You know, read any textbook, any book at all on probability, basic statistics, or just very basic inductive logic. You will find this. They will say exactly what I'm saying right now, basically word for word, which is what I'm trying to say. The people that are in disagreement, they seem to think that there's something about each individual flip matters, that you don't look at the end results. They seem to think that there's like, yes, sure, maybe there's all these outcomes, but because of how each individual coin flip works, the probability overall is somehow different. The probability of winning overall is somehow different. I'm telling you here that it's not. Just get that ridiculous notion out of your heads. It's not. The probability of winning this game depends only on the end results. And like I just calculated with this formula here, which is a fact, this formula is a fundamental probability formula, your chance of losing is 1/2 times a half times a half. It's 1/8. And again, if you don't believe me, if for some reason you think that I've gotten confused or that I don't understand what's going on, test it. Like I said, you can test it. You can test this. You can flip 3 coins, do it a bunch of times, and record percentages, and then you can tell me that I'm wrong if your evidence demonstrates that. But it won't. It really won't demonstrate that. I know that, because that's not how probability works, pretty much. Like, probability isn't really physics. You know, individual coin flips, sure, they don't affect each other, but that doesn't... A probability is just a mathematical idea. It's a number that we use to describe events. Now, I'm telling you that these events, the events of flipping 3 coins, behave like this. They don't behave the way Ryan said they do. They behave the way Gavin said they do, actually. They behave the way he said. You have an increased chance of winning Jeff's game if you're allowed to flip 3 coins rather than if you're allowed to flip 1. And if your intuition's still thinking wrong, okay, you know, I've probably driven this into the ground to anyone caring to listen. You know, just ask yourself, if you get to flip a coin, right, you have to hit heads to win, okay? Okay, you have to hit heads to win. Would you rather flip 1 coin or 1,000,000? Just answer that. Answer that question. Would you rather flip 1 coin or 1,000,000 to get heads? If your answer is 1, you are batshit fucking crazy. You are insane. That is just dumb. I think most of us would probably say, well, I'd obviously win, like, I'd rather flip 1,000,000 coins, because that's more chances. Yeah, exactly, it's more chances, which is why the percentages are different. Like, the one argument people kept, which I have already mentioned, is, oh, well, when you get heads, you stop. That doesn't matter. That doesn't change the forecast I'm making on probability overall. Your overall probability doesn't, like, your overall probability for a system when you are allowed to flip 1,000,000 coins isn't affected by individual flips. It isn't. Like, you have the 3 flip, sorry, yeah, it was a side. You have the 3 coin flips here. This one, this flip here, it's not affected by that flip. It's not affected by that flip. That's true. But the system overall, this whole system, it's affected by this flip and this flip and this flip. And the system is what you should worry about. You've gotten heads, you don't need to worry about the rest of the system. That's true. That's true. You don't need to worry about the rest of the system. But the fact that the system is there, that tells you your chances of landing, that tells you what your chances of landing in one of these, like, one of these mutually exclusive situations are. That's what the system's there for. Getting heads and you stop, that doesn't change the probability. That's what I'm just trying to say. You're like, if you, okay, I'm not going to repeat myself again, except to just conclude. The probability of winning Jeff's game depends on which of these situations you land in. That's what it depends on. You're flipping 3 coins, it depends on which one you land in. People who are saying, if I flip 1 coin and that's it, then that's 50-50. No, the 1 coin tells you where you land. It tells you that you've landed here. You stop flipping because you don't care about this stuff, because you don't care because you already know you've won. You don't care about the rest of it. But that coin still does what I'm telling you it does, and it still does contribute to the 87.5% that I said is what you would get. Right. One thing. Okay, I'm gonna stop the video again. Like, I've